Yeah, good morning, everyone. So today we will continue our class about plant utility system. But I think for this 2.5 weeks, the content of the lecture will be delivered by me. Actually, me and Pak Chandra. Pak Chandra will give in the regular class, and I will teach in this international class. But maybe later, if maybe Pak Chandra is not available or I'm not available, that I hope it's okay if we combine the class, but we will, we will try to take the class still in the parallel way. And for the materials, we will deliver about, actually we will cover 2 topics, but it's all related to water. For the first topic, we will discuss about water supply system. Yeah, so we will discuss about water supply system, maybe for about 1.5 weeks, and then another 1.5 weeks we will discuss about specifically about cooling water system, because water is one important necessities, one very important materials that used in plant operation. Actually, it's not only for the utility, but sometimes it's also for processed water. Okay. Before we start discussing about the water supply system, I think you already know, you already understand that our planet Earth is a water planet, which consists, I think it's around 70%. I hope it's still correct now. 70% of Earth consists of water. And basically, in our Earth, water will undergo what we call the water cycle or hydrologic cycles. So it will have continuous change of form, continuous process. That's why some water will be accumulated maybe in ocean, some will be accumulated in the clouds, some will be accumulated in the groundwater, etc. So maybe I think maybe you have learned about the water cycle, but I will start this class by playing some videos about the water cycle.
All the water on Earth today, every drop, is all the water there has ever been on the planet. Fresh water is actually millions of years old, the same water flowing in a continuous loop, falling as rain and snow from clouds to the Earth's surface, running in rivers, pooling in ponds, flowing from faucets, irrigating crops, traveling through plants, generating power, eventually evaporating into the air and condensing into clouds again.
Why is there life on Earth? And the reason there's life on Earth is because Earth has this perfect water cycle.
The water cycle. So simple even small children understand the basics. Yet so complex, the most advanced Earth scientists, hydrologists, geologists, and biogeochemists are studying every part and process.
The water cycle is fascinating. It's something that's around us all the time, and yet we don't really understand it.
How to summarize what is known about the water cycle? With 2 words, flows and stores. The water cycle is a series of flows of water between various water stores or storages. Clouds in the atmosphere.
There's always a little bit of water in the atmosphere. We talk about relative humidity. It's a humid day, it's a dry day. Either way, there's water, sometimes a little, sometimes a lot.
There's a lot of water in the ocean, 70% of all the water on Earth. In the ice sheets and glaciers, 2/3 of all the fresh water on Earth. In the snowpacks atop mountains like the Sierra Nevada. In the Great Lakes. In rivers and streams. In reservoirs and watersheds. In wetlands. In the soil. In and on plants and trees rooted in the soil. And beneath the soil. In water tables and underground aquifers like the Ogallala High Plains, which runs underneath parts of 8 states from South Dakota to Texas. All this storage is temporary. Water in all its forms is always in flux and always moving. And there is a name for every kind of movement in the water cycle, starting with precipitation.
Precipitation is the process of water falling onto the surface of the Earth. You can have precipitation in many forms: rain, snow, hail.
Rain is falling water in liquid form. Snow, ice, hail, and sleet are falling water in solid or frozen form. Fog and mist, falling water in gas or vapor form. Precipitation that falls directly onto the oceans becomes part of surface ocean and can be churned by wave and wind action into ocean currents. Rain and snow that falls directly on rivers and streams becomes one part of stream flow. Rain that falls onto land takes a different path to the river, as does the snow and ice that falls and collects on mountaintops when temperatures warm.
When snow melts, some of it runs through the snowpack and goes into small streams, tributaries that feed into large rivers.
What about that precipitation that falls on and over land? Some is intercepted by vegetation, plants and trees.
Like you might imagine someone in the game of football intercepting a pass. These are raindrops trying to come to the ground, and the leaves on the tree intercept them before they hit the ground.
And the precipitation that does hit the ground, it can run off if the ground is hardscaped, covered with asphalt or concrete, or if the soil is too wet or saturated to absorb more water, like an over-soaked sponge. Otherwise, precipitation infiltrates the soil surface, percolates into the ground.
Think of it as the water percolating through your coffee grounds in the morning. Gravity continues to pull it downward so it will move through.
Through the topsoil, into spaces between soil and rock particles, down to bedrock and further into fractures, into deep underground aquifers. Even groundwater here is moving sideways or laterally, discharging toward a river, lake, or the sea. Generally, the deeper the flow, the slower the flow.
Some of that fractured water might take a very long time, thousands to millions of years to get out.
And how does water get back out into the atmosphere? It evaporates, is turned from a liquid into a gas or vapor by the heat of the sun.
If you put a bit of water into a bowl and you set it outside on a sunny day, it's going to disappear. It's still water, it's just in the form of a gas rather than the form of a liquid.
Water evaporates from every wet surface, even from wet air. Some rain and snow evaporates into the air while falling. Water evaporates through our respiration and perspiration, and from plants through transpiration. Trans means through or across. Plant roots draw up groundwater.
And plants pull that water up through their stems into their leaves and then release it back out through evapotranspiration.
Evapotranspiration, a spelling bee-worthy term for evaporation from soil and water surfaces, plus transpiration from plants. Evaporated water molecules are tiny enough to flow into the air, mix with smoke and dirt particles in the atmosphere, cool, condense into visible masses of water vapor, clouds. Winds move clouds into colder air, water droplets collide and merge, grow bigger and heavier, until they are so heavy they fall again, as rain or snow, sleet or hail. Precipitation, collection, runoff, interception, infiltration, percolation, discharge, transpiration, evaporation, condensation. The water cycle.
Okay, I think from that video, you can understand again. If not that you from that video, you can see that the water will undergo a certain cycle from one form to another. So there will be some continuous supply of water and some process that requires water in order that the process should be happen individually, ya. Jadi dengan adanya siklus air itu, prosesnya kan tadi continue ya. Jadi prosesnya continue di semua tempat itu pasti nanti akan ada air di situ, hanya saja bentuknya beda-beda ya, bentuknya beda-beda. Dan the most important is the characteristic will also be different. Okay, so basically to support our life, supporting any life, that water sources that can be used, you can get from seawater. Of course, you need to apply more advanced technology, but with simpler technology, the water that we need to support the life can be obtained from fresh water. Basically, fresh water is our main source of water. It can comes from the rainwater. It can be in the form of surface water or the ground water. However, the characteristic, like I have mentioned before, the characteristic of water will be different depending on the source. So for this table, you can compare like the river and then lake and then well water and then seawater. Okay, I think the most obvious one is seawater. Seawater contain higher concentration of salt. Yeah, the salt concentrations, sodium and then potassium, will be much higher compared to other source of water. So that's why if you want to use seawater as maybe for the industry or maybe to support our daily life, we need to remove this salt, because if we do not remove the salt and it's still maybe you consume salt in high concentration, then it will be endanger your life, of course. Or if the seawater directly used for industrial process, then it will create problems, scales or corrosion and something like that. So basically, for seawater, the main parameters will be salt. The main problem with seawater will be salt. How about the well water? Well water basically is the one that mostly used in industrial process, but some well water will have like mineral composition that quite high, because in deep water or well water, might have dissolved some minerals from the rocks, from the bebatuan, ya. Jadi kalau di air sumur atau deep water itu biasanya kandungan mineralnya itu lebih tinggi. Okay. And also we can see from this table that the differences, the different source of water will also correlated with other parameters like dissolved solid. Basically, dissolved solid comes also from the salt concentration, actually, salt and other mineral concentration. But also we do have other composition, other compounds as well, like calcium carbonate, and then other component that's also cause what we call hardness. Yeah, we will discuss about the hardness later in our discussion. Ya, jadi selain tadi ada mineral-mineral, garam-garam gitu ya, kemudian ada juga yang disebut dengan padatan terlarut ya. Jadi padatan terlarut ini ya sebetulnya dari garam tadi. It's from the salt or from the other minerals that dissolve in the water. But beside dissolved solid, we also have what we call a suspended solid. It's opposite of dissolved solid. Suspended is the solid that cannot be dissolved. It will be suspended, so it will be creates what we call turbidity. Ya, jadi selain ada yang terlarut, ada juga yang tersuspensi. Tersuspensi itu melayang-layang. Jadi dia tidak terlarut, sehingga nanti larinya adalah ke turbidity. Oke. Okay. Although previously we learned that our planet is water planet, where 70% of water are in the ocean, right? So if 70% of our Earth will be in the form of water. However, most of the water are in ocean. So it will be in the form of seawater with the characteristic that I have previously mentioned. Ya, jadi walaupun air itu banyak ya, di bumi ini banyak air, tapi sebagian besar itu ada di laut. Itu akan berupa air laut, air garam, where the salt concentration is quite high. So if you want to use this seawater, then you need to apply more advanced technology. But with the simple technology, what you can actually use is the groundwater and surface water, which consists only, how much is this? 0.1%. Like 97.5% of water are in ocean, but the one that you you can use directly, yeah, with, of course, you need to treat it before you can use in industrial purpose, but the one that you can use is only roughly about 0.1%, which is in the form of groundwater and surface water. So it's very little compared to all the water in the earth. And also, what we this is one problem, right? Because it's only a very little part of water that we can directly use. And also the quality of this groundwater and surface water is decreasing throughout the years. I think the quality of water like 10 years ago, 20 years ago is much better than now. And we can expect that the water quality later, 5 years from now, 10 years from now, and it will be decreasing much more. So that's one problem that we need to be aware of. Okay, because our class called Plant Utility System, maybe before I go to the next slide, can you guess in industry, especially in industry, water are used for what kind of purpose? Jadi kalau di industri sebetulnya air itu dipakai untuk apa? Anyone can share your opinion?
Sir, is
Yes.
one of them cooling system?
Okay, for the cooling system, yes, correct. Is there any other purpose that we need water in industry?
Can I answer, sir?
Yeah, sure.
Dyeing, sir?
For dyeing. Dyeing
Yeah.
means coloring the textile, okay?
Yes, sir.
Yes, okay. Any other?
Maybe to make steams, sir.
Yes, to make steams or for steam generation. Okay, any other?
Cleaning, sir.
Okay, for cleaning. Yeah, of course. Yeah, that's, I think you already get the you can guess the content of the class, right? So basically, water mainly used in industry as for utility purpose. Utility means water is used to support or water is used as the supporting materials, whether it's for the direct and indirect activities. Direct means it's correlated to the process. Yeah, to correlate with the process. For example, like to generate the steam, we use boiler, yeah, to generate the steam, to heat up the water so it can create the steam, and then the steam can be used for other purpose. And then for cooling, yeah, for the cooling, normally we can use heat exchanger, and then we can use a cooling tower in the cooling system, and it's also using water. And then for the processed water, basically for the processed water, we use directly the water in the process. This one is the utility, right? The steam cooling is for the utility. It's supporting. But for the main process, we call it process water, air proses. Ya, jadi yang steam atau pendinginan itu adalah utilitas ya, pendukung. Kalau yang digunakan secara langsung di dalam proses, kita sebutnya air proses. Air proses misalnya apa? Tadi yang disebut for dyeing, for the coloring the textile, we need to dilute the what we call the coloring agent into the water, and then we process the textile. And also, if you for the beverage industry. Yeah, beverage industry, the water will be the main component for the raw materials. Yeah, the raw materials. So it will be part of the main necessities of the process. Okay, that's the direct activities because it's directly correlated with the process. Even though some are considered utilities, some are considered raw materials or processed water. For the indirect, yeah, you have mentioned is for cleaning the equipment, cleaning the floor, cleaning the building, for example. And then for the fire extinguishing system, yeah, because for large plant, we cannot rely on just fire extinguisher that you normally see in the house or in the building, but we need to employ what we call the hydrant system. So it's using water with high pressure, so it can reach quite certain of length. So that's why water is also required for this process, and also for drinking system. Just don't forget, right? Maybe not maybe, yeah. The water is also used in the drinking water system. This is the indirect activities. Any question until this part?
All good so far, sir.
Okay. Since you mentioned that water is used for dyeing, Kevin, can you tell us how much water that you need to dye the textile? Maybe per square meters of textile, or maybe per ton of textile? I forgot the units.
Actually, I do it like per ratio gitu sih, sir. Like
yeah, the ratio is between
1 to 4, sir.
1 to 4.
So like
it means
like for example 1 kilogram or 1 ton of fabric, you will use 4 liters or 40 liters. 1 kilogram of fabric is equal to 4 liters of water, or something like that. Yeah.
Okay, so roughly around 4 liters of water is equal like 4 kilograms of water, right? So like 4 times compared to the raw materials, right? So like around 4 liters of water is required to treat 1 kilogram of fabric. Okay. Yeah, that's quite a lot of water, right? So in textile, and then for pulp and paper, normally water are abundantly used in the process. Ya, jadi dua jenis industri yang sering menggunakan, bukan sering ya, banyak menggunakan air itu adalah industri tekstil dan industri pulp dan paper. Itu cukup banyak menggunakan air. Kalau beverage ya jelas ya, karena itu adalah bahan bakunya. Kalau di sini digunakan sebagai air prosesnya. Okay, since I mentioned water in pulp and paper, I have one other video that you can watch. But basically, this is not. This is a video that made from one company that the main operational is to treat the water.
By 2050, the world will need 30% more energy, 35% more food, and 40% more water. Water is the lifeline of the paper-making process, used as a medium to transport pulp, conduct and retain heat, form final product, and remove contaminants. Without it, product cannot be made. The paper industry is challenged to balance its water use to meet economic, social, safety, and environmental objectives. On average, 7,800 gallons of water are required for 1 ton of paper, positioning the paper industry as one of the top industrial freshwater users. Although viewed as cheap and abundant, water of the right quality is becoming more scarce. Without it, production curtails, loses operational efficiencies, or produces off-spec product, causing lost revenue and eroded margins. It can also become a cost risk as water prices increase due to regulatory concerns.
Present in over 750 mills globally, Nalco Water knows how to reduce, reuse, and recycle water. Our solutions and expertise minimize overall water use and maximize on-machine efficiency and final product quality while optimizing total cost of operations. Water entering a mill can contain contaminants not fit for production. Nalco Water treats this influent before and while it circulates through the paper-making process, which includes pulp, stock prep, and paper machine. During this process journey, water is recirculated up to 10 times and combines with Nalco Water chemistries to enhance plant productivity and product functionality. It is also part of the critical boiler and cooling water systems, where we provide solutions that maintain production uptime while saving on high energy costs. In a typical mill, up to 88% of the water is returned to waterways, while the remainder is carried off as evaporation, waste, or in final product. Nalco Water treats the final effluent, which can be recycled for production or discharged back to the community.
Water is the lifeline of a paper maker. At Nalco Water, our job is to make water work optimally for that paper maker, delivering eROI results. We partner with our customers to ensure the sustainability of their operations for years to come. Minimize water, maximize results, optimize costs. Together, we can reach profitability and sustainability goals.
Okay, the video is about Nalco. Nalco is one industry that dealing with the water treatment. So not all plant or all industry have their own water treatment plant. So some industry are specialized. Some company are specialized in treating the water, and then they will supply the water that match the characteristic required by the other industry, and then they will be charged for the water. Okay. So basically, this company is one type of the company that you can apply after you graduate, ya. Jadi Anda bisa setelah lulus nanti bekerja di perusahaan semacam ini. Jadi perusahaan yang memang bisnis utamanya itu adalah mengolah air untuk industri, ya, bukan PDAM ya. PDAM kan untuk minum. Jadi nanti biasanya ada di kawasan industri, mereka akan mendeliver air ini untuk pabrik-pabrik yang lain dengan biaya tertentu tentunya. Okay. Since previously you have understood that we need water, for example, to get to produce the steam, or maybe to cool the process as the cooling water, or maybe to dye the textile, or to process the pulp and paper. So basically, the quality requirement of the water will be different. So there is no one water for all, for example. So the quality requirement will be different, and it will be depending on the objective of the water usage. What kind of the purpose you're using for the water? Of course, the water to generate steam, the characteristic of the water that you need to generate steam will be different with the water that you need to produce a beverage. They're different characteristics. And we know for sure that water that you get from either is from the surface water, or maybe from the deep water, the well water, will be it will be not suitable if you use it directly for the process. So water from nature usually has not fulfilled the requirements. So it needs to be treated. So it needs to undergo the treatment process. For example, this is the for the boiler, yeah, steam for the boiler. Basically, we have three types. In general, we have three types of boiler, which is low pressure, medium pressure, and high pressure. Yeah, depending on the pressure. So each type of the boiler, the characteristic of the water requirement will be different. In general, the higher the pressure, the water purity should be higher. Yeah, you can see that for the total solid, for example, if for low pressure, you can have a total solid until, this is the maximum, right? So the standard, or in bahasa, we call it baku mutu. Baku mutu is for limbah, but it's normally we use it as standard. Standard is the maximum value that you can have. Yeah, for the low pressure, you can have total solid until 3,500. But if you operate boiler in high pressure, the maximum may be only 500. And also for other parameters like alkalinity, total suspended solid, and silica. We will discuss about silica later because it's quite troublesome in operation if you have a high content of silica. Okay, this is for the boiler, just for the introduction. And also, if we want to use cooling water, then some requirements, including conductivity, turbidity, suspended solids, should match the standard as well. Ya, jadi untuk cooling water juga sama ya. Jadi beberapa parameter itu harus dipenuhi. Ya, so jadi tidak ada parameter, maksudnya beda kebutuhan karakteristik dari air itu pasti akan berbeda. Okay, but before we understand, in order to understand further about why water can have a total solid, why water can have alkalinity, or why water can have a conductivity, for example, why different sorts of water have different pH, for example, then I think you need to understand about the water chemistry. This is basically a basic chemistry, but I have one other video, so maybe today I'll play quite lots of video as the introduction. From this video, hopefully you can understand why water can have some distinct properties and have some parameters that eventually we need to treat the water in order to be able to use in the industry. Until this part, maybe you have some question first. Apakah ada pertanyaan?
All good, sir.
Okay, if you have no question, then I'll start the video.
Water is an interesting substance with a chemical makeup that gives it some unique physical properties. A water molecule has an oxygen atom with two hydrogen atoms connected to it by covalent bonds. The V shape that the molecule makes is caused by the way that the oxygen atom's valence electrons repel one another. These covalent bonds are made up of a pair of electrons and are the key to many of water's unusual properties. Oxygen is more electronegative than hydrogen. This means that its positive nucleus pulls harder on the negative electrons in the covalent bonds than the hydrogen's nucleus. As a result, the oxygen atom develops a partial negative charge, which leaves the hydrogens with a partial positive charge. These partial charges create a positive end and a negative end to the molecule, making it what chemists call polar. The opposite charges of these polar molecules are attracted to each other, causing them to loosely stick together. The attractions between the water molecules are called hydrogen bonds. These hydrogen bonds give water a boiling point that is about 200 degrees higher than it should be when compared to other similar substances. The result is that water is a liquid at room temperature, but other similar molecules like hydrogen sulfide, hydrogen selenide, and hydrogen telluride are all gases. The polar nature of water molecules is also the reason that some substances dissolve in water while others don't. Take salt and oil, for example. Salt is made up of charged particles called ions. In this case, we have positive sodium ions and negative chloride ions. In solid salt, the ions are attracted to one another. The partial charges on the water molecules cause them to be attracted to the ions. When the ions are completely surrounded by the water molecules, the salt dissolves. Unlike salt, oil is predominantly nonpolar. This means that it doesn't carry any charges, so there's nothing to attract the polar water molecules to it. This is why water and oil do not mix. So, water's high boiling point and the way it interacts with different substances comes down to the polar nature of water molecules. Water's properties are all great examples of what we observe on the macroscopic level being influenced by what goes on at the molecular level and how we link the properties of chemical substances to those structures. Thanks for watching, and make sure to check out the other videos in this series.
Okay, so that will be the characteristic of the water chemistry. I think from the video you can understand why water have some distinct characteristic, where normally for other compounds the phase will be in the gas, but water it will be in the atmospheric pressure and temperature. The phase will be liquid. So water will have negative pole and also have a positive pole, and between molecules they also have the hydrogen bonds. And these properties is basically makes water is a very universal solvent. Almost everything, not all, but almost everything can be dissolved in water. Okay, you already know about the hydrological cycle. Now we will focus on two types of water that normally used in industry, which is the groundwater itself, or well water, or we can call it deep water, and one is the surface water. Okay, this is the main characteristic of the groundwater. Groundwater normally have low turbidity, because from the water cycle, you still remember that when it percolate and then it's not percolate, it's infiltrate the layers of earth. The layers of earth also function as the filter. Ya, jadi ketika air itu meresap ke dalam tanah, lapisan tanah tadi berfungsi juga sebagai filter, sehingga turbiditas atau kekeruhan will be low. However, the mineral content will be high, because when it infiltrate the earth, they will dissolve the mineral that's also contained in the rock bed. Ya, jadi that's we call percolation. Jadi ketika masuk terjadi perkolasi, itu juga akan melarutkan mineral-mineral yang ada di bebatuan. And different area, water that the groundwater characteristic from one area to another will be different. It will depend on the types of the mineral content in the rock bed. So in some area you can find the water will contain very high iron concentration or mangan concentration. but in other area maybe it's low. How about the organic content? Same with the turbidity, normally it's low organic content. Ya, jadi kalau air tanah itu kandungan organiknya itu sedikit, karena ya tadi sudah terfilter oleh lapisan tanah. And normally it has a stable temperature. Okay, this is the groundwater. How about the surface water? For example, in lake, rivers, and water streams, because there is no layers of earth that fill to be as the filter. And then for the surface water, including the runoff, the water will have a high turbidity. Ya, jadi kalau surface water itu cenderung keruh, karena kan dia ngalir di permukaan gitu ya, terus kecampur-campur yang lain. So it will have high turbidity. The mineral content is varied, depends on when they flow, what kind of solids that they will percolate, they will dissolve. Ya, jadi ketika mengalir, tergantung ya, mereka mengalirnya di mana. Nanti kandungan mineralnya ya akan bergantung pada kandungan mineral di permukaan tadi. How about the organic content? The organic content normally high, because you have plants, and then you have also river is normally used for people to dump everything, right? So including the domestic waste, so it can influence the organic content in the surface water. Temperature, I think for 2 seasons country, the temperature won't be fluctuated much, but in 4 season country, that the temperature will be fluctuated. Of course, in the winter, it will be much lower than in the summer. So that's the characteristic of 2 types of water that normally used in industry. So the groundwater and surface water. Okay, the main impurities, you can see that the characteristic will be the one is the non-ionic and suspension substance. Ya, jadi salah satu bentuk karakteristik, salah satu bentuk dari impurities itu adalah senyawa-senyawa yang sifatnya non-ionic. Non-ionic berarti tidak bermuatan ya. They won't have a charge, and normally they will be in suspension form. Bentuknya adalah bentuk tersuspensi. Tidak terlarut, tapi tersuspensi. Jadi padatan-padatan tersuspensi. The second one in the form of gases. The other one in the form of ionic and dissolved substance. Okay, maybe we can see from this table. Yeah, for the non-ionic and also the suspension substance, it can comes from sand, mud, soil. I think yeah, it's easily understand. And then some organics, the leftover of people, the leftover of plants or animals, and then oil and bacteria, and also from the colloidal silica. Jadi silica actually are in the 2 form. One is colloidal silica, and the second one is dissolved silica. For the colloidal silica, it will be non-ionic, and it will be in the suspension form. Okay, this form of water impurities are normally obtained from the surface water. Yeah, that's what this. So this one is yeah, relatively easy to be separated. Yeah, because it's visible, and then it's not dissolved. It doesn't create interaction, chemical interaction with the water. So this one normally firstly separated in the pre-treatment of the water. Ya, jadi di water treatment plant tahap awalnya itu adalah menghilangkan ini dulu, karena ini yang paling gampang. Karena kan kelihatan ya, kalau keruh ya kelihatan, kalau ada depan ya kelihatan, dan lebih gampang dipisahkan. And then the second impurities are in the form of gases. Normally, the gases found in the water are from the deep water. the one that you get from the from the well that have very high depth. Ya, jadi gas itu biasa ditemukan di dalam air kalau airnya itu berasal dari sumur dalam, deep well water. What kind of gases that contain is carbon dioxide, of course, and then from the oxygen, ammonia, because they can dissolve or they can dilute in the water because of the rock bed, like the oil, the gas that in the earth bed, di lapisan tanah itu ada gas alam kan ya, there's natural gas, then they can dissolve in the water. Okay, the other one, because water is a very universal solvent, so a lot of ions, whether it's inorganic ions and also charged organic ions, can dissolve in the water, including silica. Okay, especially for dissolved silica, it's very difficult to remove. And then, you know silica, right? Anyone know silica? Silica is raw material to produce what kind of product?
Silica gel, sir.
Yeah, okay. Other types of products that you know that you do not use silica gel in everyday's life, right? What kind of product in everyday's life that produced by silica?
Glass, sir?
Yes, glass. Silica is the main raw material to produce glass. You understand the physical properties of the glass, right? It's very hard, and then it's translucent. And if you have dissolved silica in the water, and if you have quite significant concentration of dissolved silica in the water, and then you use the water, for example, to generate steam in a boiler, then it will create what we call scale, yeah, kerak, silica scale. The appearance will be like glass. It's translucent and it's hard, and it will stick to the surface of the inner part of the boiler. And it's very difficult to clean. That's why silica creates problems in water treatment. So if the water that need to be used for the process contain very high concentration of silica, it will be very, very troublesome, because it requires significant effort to remove the silica. Okay, let's see about the ionic impurities. Yeah, this is the ionic one. So ionic impurities can be exist in the water in different form. First is ionic is a charged dissolved particle. So it can be it will be consist of the positive ion, what we call cations, and negative ions or anions. It can be in the one charge, or we call it monovalent, divalent, two charge, and trivalent. Types of cations that normally present in the water is calcium, magnesium, sodium, aluminum, barium, potassium, and iron. However, how about the anions? It can be in the form of bicarbonate, or chloride, or sulfate, carbonate, nitrate, and silica. Yeah, this is the inorganic ions. How about the organics? Basically, organic ions in the water comes from, it depends. If dissolved organic can comes from domestic waste. If the water are located in the municipal area, so it will be in the form of organic. It will come from the organic waste. Ya, sampah dari manusia. Ya, taulah ya itu apa. Then another one is, do you know peatland? How to write? Just a minute. Do you know peatland? Lahan gambut? Atau baru dengar? Okay, at certain location or like in the peatland, the water contain quite a high concentration of what we call humic acid or fulvic acid. It basically comes from the plant decomposition. Although it also comes from the usage of detergent and also some industrial waste that contain the organic types. But for the peatland, it comes from the plant decomposition. It contains high humic acid and fulvic acid. In the peatland area, normally the water color is brown. It's like tea color, ya. Jadi warnanya tuh kayak teh gitu ya, coklat. And it has low pH value because of the acid compounds. So if the industry, maybe the industry are located in the peatland area, and then they want to use the water, and the water are low pH, and also the color is the color is brown, so they require certain process to treat the water. Okay, any question? Why ions are okay? For the silica, I have explained to you, right? Silica can create scales, like calcium carbonate can also, or calcium bicarbonate or magnesium can also create scales when it's not properly treated before use in the for the steam, for example. Kira-kira kalau ion ini tidak dikurangi ya atau tidak dihilangkan, kira-kira ada problem apa lagi? Atau bisa menyebutkan contoh problem apa lagi yang bisa muncul if you have quite concentration of ions in the water. For example, if you want to use the water as processed water.
Will it like trigger some sort of reactions, unwanted reactions that will trigger something
Can you
else?
give more exact example?
Like for example, in textile industry, if for example your dye needs to like link to the fabric, but since there are these elements will be the one that will link to your fabric, and you will not get your optimum quality for your fabric or something like that.
Okay, yeah, actually that's one correct example. In dyeing process, coloring the textile, it will involve certain chemical reaction, right? So dye is contain certain chemicals that needs to be covalent. I think it's covalently bond, right? Jadi reaksinya adalah pakai ikatan kovalen dengan si tekstilnya, and the appearance of certain ions can inhibit the reaction. So maybe the color will be different, or the quality of the dye will be different, for example, like that. That's why for dyeing the textile, you need to treat the ion perfectly. Or maybe in beverage industry, because in beverage industry, water will be used as the main raw materials, right? You will drink the water. The appearance of ionic compounds maybe will change the taste of the water. Yeah, that's why. Have you tried drink? There will be different taste between mountain water and then seawater, and then maybe water that you get from the lake, at the surface. Ya, jadi kan beda ya rasanya antara air pegunungan, sama-sama air bersih gitu ya, katakanlah. Kalau yang didapat dari pegunungan, tapi dibandingkan dengan yang di daerah pantai, itu akan beda. Yeah, that's why you need certain treatment to overcome to treat the ionic impurities in the water. Okay, any question until this point? Okay, if you do not have any question, or maybe you still have question, then we can discuss it at the next class. Thank you very much and good morning.
Thank you, sir.
Thank you very much.
Thank you, sir.